Hello, and welcome to Defining Rigid Motion. We've already kind of talked about what rigid motion is, but this unit in Plato just kind of nails down the definition. Rigid motion, also known as congruence or congruent figures, is where I do something to a figure. Let's say I have this triangle, and I do some sort of transformation, either reflect, rotate, or translate, or maybe something else. We'll talk about whether or not something else exists. And I get a new image of the same shape and size. If it's not rigid motion, also known as not congruent, also known as not equal, then I have done something to an image where either the shape or the size has changed. These triangles are only, for example, similar because I took one and I made it bigger. So let's review of the different types of transformations that we learned, which are rigid and which are not. Reflection keeps the same shape and size. Rotation keeps same shape and size. Translation keeps same shape and size. Does dilation? No, so that would be considered not congruent. How about a stretch? Nope, so also not congruent. If I'm bending or stretching an image the same way that if you've ever used the Snapchat filters that mess with your face and no longer looks like your face, that is not a congruence transformation. If it is a congruence transformation, the shape or size doesn't change. And in fact, these three, reflection, rotation, translation, are the only three that exist that are considered rigid motion. Anything else in our flat Euclidean real world will change the shape in some way. So you're either going to have to be reflecting, rotating, translating, or some combination. Maybe I reflect, then translate. Maybe I translate, then rotate. So here are some questions that may come up. Let's say triangle ABC is being rotated to become triangle A after, B after, C after. If angle A is 2x plus 1, and angle A after is 7, what is the value of x? Well, consider first, what is the relationship between A before and A after? Because this is a rotation transformation, the shape and the size doesn't change. So that means that this angle, 2x plus 1, and this angle, 7, should be equal because they really haven't changed, which gets us that 2x plus 1 is equal to 7. And now we go back to our algebra. So, do the opposite of what's attached. What I see in your x are plus 1 and times 2. I need to do the opposite. Opposite of plus 1 is subtract 1. Opposite of times 2 is divide 2. Therefore, x is 3. Plug it in and double check it. 2 times 3 is 6, plus 1 is 7. 7 equals 7. They're supposed to be matchy-matchy, and they are, so we're all good.